Everything started with the idea to make my own portable gaming console. People say that some ideas are dangerous. Such a thought is absurd. Why would ideas be dangerous? I suppose that a stupid idea could lead someone to do something stupid. But that would mean the person cannot distinguish a good idea from a bad one. Now we're going off topic. Do other people know to distinguish a good idea from a bad one? I cannot answer questions for others. Do I know how to decide between a good idea and a bad one? Experience says no. Now I've cornered myself, but I'm sure I can stop pursuing a bad idea very quickly. Do I really know how to realize when I'm using a bad idea? I don't know how to determine that except by trying it. Does that mean that the only way to find out whether a bad idea is actually bad is to test that bad idea? Something tells me that's how it is. I'll choose to believe that. At some point, you have to believe in something. Idea was to make a gaming console that isn't quite a gaming console. Actually, it is a gaming console, but only for chess, in the hope that no one will laugh at me for making games intended for children. Chess is still a serious game, or at least that's what I tell myself while doing this. Professional chess players, also called grandmasters, are regarded as extremely intelligent people. Which of course they are. Will this project of mine be seen that way as well? It will still look like a gaming console, it will have buttons for movement, and it will be held in the hand like the others. I don't know, and this fear of not being accepted makes no sense. But it's still there. To get back on the right track, the idea is to make a chess gaming console as cheaply as possible. That can be achieved with inexpensive components. Thank God I live in a time of affordable electronics. The heart of the console will be the so-called ESP32 S3 microcontroller. On sites like AliExpress, you can get them for just a few euros. Besides that, there is another strange thing in the idea. An e-paper screen. What is an e-paper screen? It is a screen that differs from normal LCD screens in how it is made. Usually, screens have many small pixels consisting of RGB LEDs, which increase or decrease in brightness depending on the color that needs to be produced. This e-paper or e-ink screen consists of slightly different pixels that are not really like true pixels. These so-called pixels can be black or white. If we apply a small charge to them, they change color, and likewise, if we remove that charge, they change color. This actually means that once we set the pixel to the desired state, for example black, it stays in that state even without power. An extremely interesting thing. Today, this type of screen is mostly used in e-book readers because it literally looks like paper to the eye, and the eyes don't strain while looking at it. Such technology sounds expensive, which is true. A 4.2-inch screen costs 20 euros, but there is one more great thing that could lower the final cost of the whole project. Since the screen behaves the way I described, it uses much less electrical power than normal screens, which will later mean that I can use a weaker battery. Batteries are not cheap. Alright, I will deal with the batteries at the end. That's it. Now I take those few components, connect them, and the chess gaming console is finished. That is what I said at that moment, without knowing that I was Olympic level wrong. As I write this, a sense of dread grips me. Why wouldn't I turn some attention to what the console will look like? Surely it is important that the final product looks nice, because it's a portable device and will probably be used somewhere where others can see it. Which means that when someone sees I have a nice gaming console in my hand and then notices chess on the screen, they must think I'm a genius. They would surely immediately ask me what it is, and I will say it is chess, and I am very smart, please accept me. And then that person will run away. Why did I write this? I'm not sure. Back to appearance of the console. Nowadays, it seems like we are in the golden age of portable gaming consoles. Someone might say that this age was when the PSP came out, which is actually a topic for a big discussion. The currently most well-known console is the Steam Deck. Right away, I knew I didn't want to go in that direction with the look. I want the buttons to be below the screen, inspired by the Game Boy. Today, there are many consoles with such a design. On the internet, I found one called the Anbernic RG40. That's it. That's what I want. Of course, it won't be anywhere near it because I don't have that manufacturing technology. All I have is an old 3D printer that will have to perform magic tricks to get close to that. Now seriously, There won't be as many buttons as on the Anbernic, and the part below the screen will be slightly shorter. Besides that, the margin around the screen will probably be a bit larger because it simply has to be due to 3D printing. While browsing the internet again, I found another good example of what I want. This one is probably a more realistic example because it has slightly larger margins and one guy made it himself. Also, the case is 3D printed. Now, I would like to stop for a moment and inform the listeners. I realized I got a bit carried away, and someone might get the impression that I already built all of this and I'm now just describing the process. That is the wrong impression. The console is not yet completely finished. A large part is, but a large part is not. Which means that this text contains the pain of failure I am currently going through while trying to bring this project to completion. I hope the project will be finished by the end of the text. With all this, I still haven't gotten around to talking about the controls. I'm pretty sure about how the controls will look. On the left side, there will be a so-called D-pad, like the one on a PlayStation controller. And on the right side, there will be two buttons. One button for selecting and another for canceling. In addition, one smaller button will be placed in the middle between the D-pad and the two buttons. That small button will be used for opening the menu or the settings. At the very beginning, while I was still connecting the buttons to the controller, I tried connecting 16 buttons. Why 16? 8 for rows and 8 for columns. That's how squares in chess are marked, and it's easy to input coordinates. For example, D2, D4, and the pawn moves at the start. But when you really think about what the device would look like with 16 buttons on it, I personally would be scared of it. At one point, I had ideas about repurposing the device into a Game Boy gaming console. Maybe it could work, but for such an exhibition, I really don't have the will or the time, and I also doubt anyone would enjoy playing games at 1.3 frames per second. It would have to be some slow game, maybe Pokemon, but even that would torture the player. Just to be clear, it's not that I gave up only because I don't have time. I also don't have the knowledge. For that attempt, you would need a world-class level of research. Regarding coding, that is a video of its own, and I don't know how well I can explain those things. Programming chess is nothing new. Many people do it to create chess programs, the so-called chess engines. There's one interesting thing I came across. It's called FEN, or Forsyth-Edwards notation. It's a way to write down the entire board with all positions in a very short form. Well, not too short. Around 50 characters depending on how complicated the board is at that moment. The maximum is 92 characters. When I said interesting thing earlier, I didn't mean extremely interesting, just a tiny bit interesting. Besides that, a tiny bit interesting is also the chess engine that exists for microcontrollers. Under the name MCU Max, it is a chess engine made by a person named Gisio, aka Absolute Madman. I added that last part myself. What happens in that code I really don't understand, nor am I ready to understand. Maybe I'm afraid to understand. Maybe something bad would happen to me if I understood it. Gisio took another chess engine named Micromax and shrunk it so that it can run on a microcontroller. I recommend checking out his GitHub. The excellent thing is that the Absolute Madman, aka Gisio, released that code under the MIT license, which means I can use that code in my own code. It's like Christmas came early and twice in a row. But it's not over yet. That code is entirely contained in one file. And to find the best next move, you just call one function in which you pass the FEN notation of the board, and it returns the FEN notation of the board. I don't know how to contain my happiness while writing this. Without this, the project would easily take a year. Actually, maybe even longer. Up until I figured out how to code a chess engine. Maybe 10 years. The further plan for the finished product is to make some sort of menu before starting chess. In that menu, there would, for example, be options for selecting chess, playing chess puzzles, maybe even multiplayer against someone who is in wireless range and has the same console. But now this last thing I said too enthusiastically. I don't know if that will be possible when it comes to me.
Can I have multiplayer, please?
No, we have multiplayer at home. Shut up.
At the moment of writing, I paused and wondered whether I would have enough memory for all of this. The most memory is taken up by the images of the pieces and the board, because one of the plans is to implement changing the appearance of the board and the pieces. But it seems that the most space is taken up by the chessboard, which is 300 by 300 pixels, so that is expected, and then the pieces, which altogether take up less than the chessboard. Of course, there are also the libraries being used. There should be enough space because currently 2.5 megabytes out of 16 megabytes total is used, which means I can add one or two more boards and a few sets of pieces within that. If that weren't the case, I would have to include an SD card, which would be overkill, and the system would be more complex and more expensive to make. Another revelation for the listeners: this project has been going on for a few months already, and some things have been removed, then added back, then removed again. It's difficult for me to set any concrete rule that the project must follow. Anyway, why am I talking about this? About a month ago, I was really curious about how to design a PCB. I had never done something like that before, even though I have basic electrical engineering knowledge. I simply never had any contact with PCBs. Well, where better to start than by designing a board for this project? The board is extremely simple. The most complicated part was figuring out how to make the battery charging system and the ability to play while the charger is plugged in. This sounds silly, but the charging system is actually quite complex. Anyway, I managed to design the entire board, and I sent it to a company that manufactures and assembles PCBs. After about a month, the boards arrived. In fact, as I write this part of the text, the board is on my desk. To make a long story short, the damn boards don't work. I would love to say it wasn't my fault, but it is entirely thanks to my brilliant mind. In my enormous intellect, I managed to mess up something a child would foresee. I had a voltage of 4.2 volts, and I needed to reduce it to 3.3 volts. This is done using a simple method where the voltage is divided into 3.3 volts and 0.9 volts, and then we take the 3.3 and connect it somewhere. I somehow managed to take the 0.9 volts instead of 3.3 volts and connect it to the ESP32, and of course that can't work because it's far too little. So my first experience designing a PCB couldn't have turned out dumber. But alright, it taught me some things that I will use next time when designing another board. It turns out I can make a much smaller PCB, almost half the size, which will reduce the cost, and besides that, now I know how the process goes and what kind of questions the PCB company will ask me. Now that I remembered what I already know, I also remembered what I don't know. I don't know how to make a D-pad for controls like on gaming consoles. I've seen that there are various ones to buy online, but I don't know how I will determine the dimensions for the buttons underneath. Which micro switches or buttons should I use under the D-pad? I will most likely ask that on some forum or Discord server. In my experience, whenever I asked a direct and clear question, an answer always followed. Even Reddit is a good place for that because more people will answer the same question with different opinions. But there's still time until then. I think this essay will come to an end soon, and the rest will be documented in the next essay or text. Either way, I'm ashamed to call what I've written so far an essay because it's awful. Besides that, an AI voice will read this and I don't know what it will sound like. Actually, I do know. Not good. Actually, I'm going to end this so-called essay here, because if I now start talking about the design and plans to make it, I'll take away content from the next video, that is, episode 2. Why 2 videos? Why not just one long video? I think it's because it's easier for me to make 2 small ones than one big one. When I have to edit one big text and video, I immediately lose all motivation and don't finish it. This way, everything will be split into prototyping and design and printing and whatever else ends up in the next one. Imagine that next time I do everything, design the case and send the board for printing, and something is wrong with the board again. I think that would be a sign. That would probably be a sign that I should stop with this nonsense and go do something useful. Go chop wood in the forest or something like that. It's unbelievable how I managed to annoy myself while writing about how I did something. Thanks for listening. If you made it to the end of this text, that means you are the greatest. An absolute beast.